Unit 6, this is the prerequisite to Chapter 6, and a little skills check on ratios and proportions. To simplify a ratio, you just put it in simplest form. A ratio is just a comparison of two numbers. So you can think of that as a fraction. And as long as the units are the same, they will cancel out so that you can just reduce the number. And this reduces by 4. In the second one, though, I cannot reduce the 4 over 24 because if you take notice, the units are different. I have feet and inches. So I need to make sure that I'm in the same units. So I'm going to change feet to inches by multiplying it by 12 inches in a foot. So we have 48 inches over 24 inches. Then the inches cancel, the units cancel, and I can reduce. And again, it's a comparison of two numbers, so the 1 needs to be a part of the ratio. In using ratios to find dimensions, I know the perimeter of the doors of this barn are 64 feet. The ratio of length to height is 3 to 5. So I like to draw a picture, length and height, 3 to 5. But I know that's the most reduced fraction, so I reduced it by some variable x. Perimeter is 2 times the length plus 2 times the height. So 2 times 3x plus 2 times 5x must equal 64. And you get 16x equals 64. X equals 4. So that means my length is 3 times 4, which is 12, and my height is 5 times 4, which is 20. It's asking for the area, which is length times height, 12 times 20, or 240 feet squared. Okay, you should try the following problems. Pause the video and try them. And this problem is similar to the one we did before. We have a rectangle, and its ratio of length to width is 5 to 2. And we're just trying to find the length and width this time, not the area. So we're going to do perimeter formula. Using extended ratios, it just means that it's more than two numbers being compared. So we have the measures of angles in the extended ratio 2 to 3 to 4. So we have this triangle. So we have 2x, 3x, 4x. So I know those added together must equal 180. So x equals 20. So my angles are 40, 60, and 80. So go ahead and pause the video and try the triangle problem. We have properties of proportions. First one is the cross products property, where if we have the proportion of A over B equals C over D, where B and D do not equal 0, then the cross products are equal. AD equals BC. So this ratio is an equivalent, or this proportion is two equivalent ratios. So you're looking at the cross products of 3 times 4, that equals 12, and 2 times 6 equals 12. So you use that to solve for variables in a proportion. So just do cross products, making sure when you do an expression that you put parentheses around it so you remember to distribute. And our last example here, you want to set up a proportion and estimate the number of spectators. Some additional properties of proportions. The reciprocal property is where they just turn upside down. So A over B equals C over D, then B over A equals D over C. Where you can interchange the means and the extremes. So A over B equals C over D, you could put A over C equals B over D. And you can also do where you add a value to each ratio's denominator to its numerator. So where you take B and add it to the numerator, you have to do the same thing then in the second ratio. And that's it for the prerequisite.